All right. So question 5 from your practice problems. If you remember when we were talking about Newton's third law, folks, thanks. If you remember when we were talking about Newton's third law, I said there was one question in your problem set where you've got to apply Newton's third law to solve it. Here it is. Right? It's even in the hint, apply Newton's third law, right there in the end. Newton's third law says that the force, for opposite and equal forces, for every action, there's an opposite and equal reaction. So you picture this kid stepping off, but they kind of trip or fall. So the skateboard goes one way, the kid goes the other way, and like backwards. So the skateboard goes flying one way, kid goes flying back the other way. The net force on each object is the same in magnitude, absolute value, but they're only opposite based on direction. So to solve this problem, that's kind of the setup. The the net force acting on the child, like the magnitude, and I'll use the absolute value signs. Whoops, sorry. I just want to move that. The net force acting on the child is the same magnitude, absolute value, the net force on the skateboard. That guides you with what math to use. So just write out the formula for each object's net force. So net force on the child is the mass of the child. Remember, F net equals ma. Just write it up here. So the mass of the child times the acceleration of the child, so C for child, mass of the child times acceleration of the child equals mass of the skateboard, so SB for skateboard, acceleration of the skateboard. If you kind of set this up at first and then go back to the problem and pick your numbers, you're going to have one unknown variable, one unknown acceleration, and you'll be able to put numbers in for the rest of them. Um, don't show that again, thanks. Stephanie, does the setup help? Does that make sense before I do the math? Yeah. Okay, two forces are equal. So no, it gives us one. The last acceleration in brackets is the answer. That's what we should get. It gives us two masses. One's a skateboard, one's a child. What is the acceleration of the skateboard? That's what it's asking us for. It tells us, and the wording is a little bit weird, but if you read it carefully, the acceleration, that 0.5 that's given, is of the child. Right? So the child steps off the skateboard. They kind of make it a little bit ambiguous because they put the mass of the skateboard there too. But that 0.5 is that of the child, if you kind of watch the wording. Okay. So I'm going to put these numbers in. Mass of the child is 20. Acceleration of the child is 0.5. Mass of the skateboard is 3. And the acceleration of the skateboard is what we're trying to find out. So this is 10 equals 3 acceleration of the skateboard. So divide both sides by 10, or by 3, sorry. 20 times a half. 20 times a half per 10. 3.33 meters per second squared is our acceleration. You can kind of do it in two steps by calculating the net force in the skateboard, take that number, make it equal to the net force for the child, but it works out to be the same steps.